Thanks for coming. So this is going to be an intro to on-chain data, analytics, science, getting data from chains because that's what they're all about, storing data in a way that's reachable, accessible for everybody. And it's going to be a bit of an intro, so if you're advanced, it may not be that relevant, but some of the conclusions that you can draw from the graphs and such, might be interesting for you still. So I'm at Block Demon. I'm a data scientist there. Got a couple of my colleagues in the crowd here. Come, come speak to us if you're interested in what we do, and hope you enjoy. This is all done in Jupyter Notebook, and I'm presenting it in slides. So it's going to be going through some of the code, and then some of the results from that code. So what I want to do with this presentation is show you kind of how you can take a more data-driven approach to making decisions on-chain. And here we're going to be taking the Bufficorn NFT as what we're going to dive into. Can I get a show of hands? Who has Python experience here? All right. And how many of you like Python? Nice. Great, so we're going to be digging into the data that's logged on the chain. And besides block data and transaction data, we have access to a whole bunch of different things. What we're most interested in here is event data. Some of the use cases for getting data directly from the chains is this. So we recently at Blockdaemon acquired AnyBlock Analytics, where we had produced various metrics and graphs to understand how the chains are doing, how gas fees are, how the network metrics are at the moment, and so on. This, for example, is a dashboard that shows the Lido tokens and staked ETH, and how much volume there's been, and how many holders there are, etc. So let's dig into it. What do we need? We need the data, of course, but we need to set it up with Web3 Pi here, where we're going to be using the Blockdaemon Ubiquity API suite to create an RPC endpoint for Ethereum. And what we need for that is the Bufficorn address, so I've got that right here. 0x1e, etc. And we need the ABI from the contract. You can get that from Etherscan, which is why I linked it up here. You just put it in and plug it into Web3 Pi, as I do here. So with our RPC endpoint, you need to pass a bearer token, which you can get from just signing up on our website. And here I want to plug our bounty. If you use the Ubiquity API for any of the projects during this hackathon, definitely apply for our bounty because you'll be eligible by just using here, our API. So what this looks like then is here you have your contract, and then you can start calling the functions that you can also see on Etherscan, such as the name. And here, based on the address that I plugged in and the ABI, you can see that the name of this NFT set is the Bufficorn Biddle Brigade. And then we can start pulling more from it here in a loop. You make a bunch of calls to the chain, and you can fetch each individual owner of the Bufficorns. Here you see 0x01 owns 2 of the first 5 in the index. These are NFTs. 1, 2, 3, 4, and 5, but that takes a lot of, that's a lot of requests if you wanted to fetch all 10,000 or 8,000 or however many there are now. So we don't want to do that generally. We can also fetch other stuff. Here's the metadata that's stored on AWS, unfortunately, so which is not good, guys. But yeah, taking the image for this individual Bufficorn, I think this was one of the more expensive ones. It looks quite cool. Right, so like I said, all this metadata is hosted on AWS, and what we also do at BlockDaemon is index NFT data. So we pull that metadata and those images, and we store them in our suite as well. So in that way, even if ETH Denver ends, and even if they stop paying their AWS dues, then we've still got it. But the good thing about an index such as this is you don't need to query the chain every time, right? You can get it from us, from a primary data source, instead of from the decentralized data source. And here's an example of me using our Ubiquity API to pull that data. And you can see it's stored with us here, the image, and the metadata is as well. And so if you wanted to get a bunch of information about these NFT sets, it'd be quicker to do so with an index than directly calling the chain. Right, but moving on, we also have an Elasticsearch index where you can get all sorts of event logs and transactions and whatever. But now we're going to go into events, and specifically here the transfer event. You can plug in a JSON query and get all of that. But I think I'm going a bit too slowly, so I'll just move on a bit further to the results. So you start seeing something. So I've fetched all the transactions of the since the inception of the Bufficorn using this Elasticsearch query, and we can see there have been 12,000 transactions. And if the from address is 0, that means it's a mint, right? And if it's not, it's a transfer. And we can, 12K results is quite a lot. It's quite a busy NFT project. But let's see how who holds the most, right? Because that's the most interesting bit always. Here's a list of all the owners of Bufficorns. And we can see the number 1 address holds almost 1,300 Bufficorns. And this happened about 4 days ago, actually. But it's not an individual wallet. It's a contract, but I don't know what's going on there. They amassed a whole bunch of Bufficorns 4 days ago. Second one is the mint address, so we're going to be excluding those. And then we can assume that the top holder has 291 Bufficorns, which is still quite a lot. I only have one. Right, but let's see whether they're actually transferred or just minted. Like I said earlier, if we take the 0 address as a minting event, then we can classify them into transfer or minting, and then show that most movement on chain was through minting, 82%. But that doesn't say much. So let's look at it over time, and you can see right here before ETH Denver started, or the first few days of ETH Denver, there's a huge spike in minting interest. And that is actually 4 days ago when that one address got 1,300 Bufficorns. I haven't looked into why that happened, but maybe somebody here knows. Great, then we can also see when they're minted. This is, this could be relevant for different projects, but I don't think it's very relevant for the Bufficorn right now. But I'm going to show you kind of how it looks. Taking all 12,000 transactions, we can group them by weekday, and then show them all as a heat map. And then you can see that most people minted on Saturdays or Monday, very late at night, UTC. Now, more interesting, what was the gas cost for all of these Bufficorns? We can run another Elasticsearch query and sum up all the gas costs, and you can see that all Bufficorns that were minted and transferred have cost 128 ETH total in gas fees. So in fiat, if we pair that with CoinGecko data, we can see that it was a considerable amount of US dollars on this day specifically, which was 4 days ago again. $44,000 were spent on gas fees minting Bufficorns. In total, $470,000. Now, all right, I'll show you kind of what you can do with this. Does anybody here play DeFi Kingdoms? You know DeFi Kingdoms? Yeah? Yeah, so it's a play to earn game, and you have NFTs, you can breed them, and I think they have over 120,000 heroes now, and they keep it. You can quest with them, you can trade them, you can sell them, and yeah, breed them, and you can take a very data-driven approach to this and optimize it, optimize your strategies by going directly to the chain, because a lot of the information that is on-chain isn't being shown in the front end of the game, because it would make the game a bit too confusing, right? Because all the metadata it would really clutter up the front end. But if you dig into the chain, you can just work with the data exactly how you need it. So here I show hero sales. Ignore these two dips. This is when my code stopped working. But after that, it's been continually working. But this is hero sales over time over the past almost a month. You can see it's been dipping, and there's been less interest in buying heroes in DeFi Kingdoms. So this may influence your decisions on whether you want to buy an NFT now, or one of these heroes now, or you want to wait. Here I'm showing the amount of heroes in the tavern, which is increasing, so there's more supply, and which makes sense that, or less demand, which makes sense that the price is going down. But if you see here, the median price of all heroes in the DeFi Kingdom tavern has decreased. Right, but if you have all of these data points, if you've collected all of this data and the metadata of all the heroes that have been sold over the past month, then you can parse it using something like this, where you want a very specific hero. You want to make sure that you're not overpaying for that one. You want to because yeah, there's a floor for all heroes, but then there's individual floors based on the signals that you want. So if you have a very specific type of hero you want, you're going to be looking at a different floor than the overall floor, because it might be they might in general be more valuable. So here I've appended a couple of signals, or it parses all heroes in my data frame to see whether the heroes of interest or not. And then I remove the ones that are not of interest, and then graph only the ones of interest. So you'll see there's a different price, median price, for these interesting ones that I actually care about, because there's a lot of useless NFTs on there as well, heroes on there as well. And you can then also set up, you can go take it a step further and further, and you can set up some sort of algorithm to make sure that you immediately buy a hero that matches the parameters you've set. And yeah. Great. This is a bit over-optimized, I would say, for a game, but if that's your thing, it's my thing, then enjoy. I'll be around if you want, if you have questions, or join our Discord to have access to this code. I'll upload it there, and you can also get a POAP and get more info on our bounty there.